Welcome back to Linear Circuits. This is Dr. Ferry. This lesson is on mesh analysis. The objective is to introduce mesh analysis in order to solve circuit problems. Mesh analysis is one of my go-to methods for solving circuit problems. I can look at a circuit that's fairly complicated. I've got multiple sources in there and lots of resistors, and I want to come up with a systematic way of solving it. Maybe I'm solving for a particular voltage or a particular current. The mesh analysis relies on the prior concept of the Kirchhoff's voltage law, which is the sum of the voltages around any loop is zero. And in fact, the mesh analysis is a systematic application of the Kirchhoff's voltage law. There are three basic steps in applying mesh analysis. First, to define mesh currents, one for each non-inclusive loop. By non-inclusive, I mean the loop doesn't include any other loops. So I've got three non-inclusive loops here. And I define these mesh currents to be I1, I2, and I3. And I give it a direction of the current flow around that loop. And then I do a KVL for around each of those loops, and then I solve for the mesh currents. In this particular case, the only unknowns in my equation should be these mesh currents. So even if I have another variable floating around in there, I ignore that variable for the time being. I try to write my equations only in terms of those mesh currents. Now let's take a look at coming up with the equations for this particular circuit. Now in coming up with the equations for this example, we're going to need to use the KVL. And in using the KVL, we're going to need to be able to find the voltage across a resistor like this. Well, that means that we really want to know what the current is through this resistor. Now I'm going to put something off to the side here. Suppose we have a resistor like this, and the voltage is equal to IR, Ohm's law. But suppose our current is shown in terms of these branch currents. So we've got one branch current going this way, and then another branch current going this way. The combination I is equal to I1, which is going in the same direction as I, minus I2, which is going in the opposite direction. So then this voltage across that resistor is R times I1 minus I2, like that. So we use that in being able to do the KVL around these loops. So let me start with the I1 loop. Applying the KVL around that. Let me start at this point here, and I'll do it in this direction. And I've got a minus V1 plus R1 times this mesh current plus R2 times the current going in this direction. Well, that current going in this direction will be equal to the I1, which is in the same direction, minus I3, which is in the opposite direction. Let's see, I've got three terms here, and I've got three terms around the loop, so I'm done with that loop, is equal to 0. Now, I2 loop. We do not do a KVL around the I2 loop because I already know what this current is. The whole purpose of doing a KVL is to find the mesh current. Well, I know the mesh current. I2 is equal to I sub S, because it's going in the same directions, I sub S. So then I just go on to the I3 loop, and let me go ahead and start, say, right at V2. So I've got V2 going around here. In this case, I'm going to be looking at the voltage from here to here, and that means the current is going to be going in this direction. If the current is going in this direction, then I'm going to be looking at I3, which is in the same direction, minus I1 in the opposite direction. That's the total voltage drop across that resistor from this direction. And similarly up here, if I'm going in this direction right here, I want this voltage drop from here to here, then I'm going to be looking at that branch current there. So I've got R3 times the I3 in the same direction, minus I2, which is in the opposite direction. And then coming around here, I've got one more term, and the Ohm's law on that term is R0 times I3 is equal to 0. And let's see, I've got 1, 2, 3, 4 elements across here, and I've got 4 terms in my I sub 3 loop, and that's it. So right now I've got really 2 equations and 2 unknowns because I2 is known. I'm assuming my source is known. So I2 is known. Wherever I see an I2, I substitute in I sub s, and then I just end up with 2 equations and 2 unknowns, and I can solve that for I sub 3 and I sub 4. And once I solve for I sub 3, I can go back and solve for V0. So let's look at this example right here. I want to first define my 2 mesh currents, I1 and I2. And then I want to do a KVL around, say, the I1 loop. So I start with minus 15 plus 10. Going around in this direction, I would have 10 times I1 plus this resistor, let me give it 5 ohms. So if this is 5 ohms, then I would want to solve for 5 times I1 minus I2 equals 0. If I simplify that a little bit, I would find that I've got 3 times I1 minus I2 is equal to 3. Then I do the I2 loop, same sort of thing. I'm going to start out with over here, 5 volts plus 5 ohms, I2 minus I1, going up here, plus 4 times I2 equal to 0. And if I solve these, there I've got 2 equations and 2 unknowns. I solve them, I would get an I1 is equal to 1 amp, I2 is equal to 0 amps, which is kind of interesting. It means that there's 0 current going through here, and all the current goes in that direction. Now suppose the original question had been solved for this current right here. Well, if I'm going to use mesh analysis, I first solve for I1 and I2. Those are my unknowns. After I solve for I1 and I2, then I go back and solve for whatever voltages or currents I need to solve for. So everything has to be written in terms of my mesh currents, and those are my unknowns. We're going to set up a quiz here. For this particular circuit, how many unknown mesh currents do you need to solve this? Okay, in this case, the answer is 1, because we've got 3 mesh loops here, but 2 of these are known. We're assuming that the sources are known, so this is the only mesh current that you're going to need to solve for. Here's another quiz I want you to do. I want you to solve for the equations that result from using mesh analysis of this circuit. Now here I've used a dependent source up here. Don't let that scare you. It's a current source. Pretend that we know this value when setting this up. In other words, don't do a KVL around this loop. All right, the solution is I do start with a KVL around this other loop. I get minus 3 plus R2 times, everything's got to be in terms of mesh currents. So I've got I2 minus I1 plus R4, I2 equal to 0. Okay, and I need one more equation because I've got 2 unknowns. Well, my equation is that I've got I1 is equal to minus 2 times little I1 because it's in the opposite direction. And I1 is the net current through this, which is equal to, let me put the minus 2, I1 is equal to I2, which is in the same direction, minus I1, which is in the opposite direction. So now I've got 2 equations. I1 is equal to minus 2, I2 minus I1. So that's one equation in terms of my mesh currents. And then this is the other equation in terms of, again, my mesh currents. The key concepts we've covered in this lesson, first of all, is that mesh analysis is a systematic application of the KVL. The number of mesh currents is equal to the number of equations needed. The variables are mesh currents, so make sure that whenever you write your equations, you ignore any other variables. The only variables should be those mesh currents. Avoid common mistakes that students make. One is the polarity in the current direction. It's very easy to get mixed up on those. Do not do a KVL for a loop with a current source. You don't need to. The current source already defines what that mesh current is. And also, while you're writing the equations and you're trying to solve for those mesh currents, ignore any other variables than those mesh currents. Solve for those afterwards once you know what your mesh currents are. All right, thank you.